Why did Meta acquire this robotics company with only 20 employees? On May 1st, Meta completed its acquisition of Assured Robot Intelligence, AI, a robotics AI startup, in an undisclosed transaction. AI co-founder Xiaolun Wang, associate professor at UC San Diego and former NVIDIA researcher, subsequently announced on X that his mission is to achieve physical AGI. Meta CTO Andrew Bosworth's previous statement was even more direct: to create the android of robotics. That same week, Musk revealed during Tesla's Q1 2026 earnings call that the Fremont factory plans to go from halting Model S X production line in just 4 months. However, he immediately added, the speed of mass production depends on the slowest, dumbest, and unluckiest of 10,000 parts. These two events together constitute a formal divergence in the commercialization path of humanoid robots. ARI is a small team of about 20 people, co-founded in 2025 by Xiaolun Wang and NYU professor Larrell Pinto. Their core technology isn't building robotic arms or actuators, but rather enabling robots to understand and predict human behavior in complex, chaotic, real-world environments like kitchens and warehouses. In the words of a Meta spokesperson, ARI is at the forefront of robotic intelligence, enabling robots to understand, predict, and adapt to human behavior in complex, dynamic environments. According to eWeek, the ARI team has been integrated into Meta's superintelligence labs, working closely with Meta's robotics studio. It's noteworthy that ARI hasn't joined a regular R&D department, but rather Meta's core lab specifically responsible for superintelligence research. This means that in Zuckerberg's strategic vision, robotics is not an independent product line, but rather an extension of superintelligence into the physical world. Wang's own statements on X also confirm this logic. He said, "We believe this intelligent agent will appear in human form, and its scaling will come from directly learning from human experience, not just teleoperation." The latter part of this statement is particularly crucial. Wang is explicitly rejecting the approach of simply relying on teleoperation to expand data, instead betting on a methodology closer to learning directly from human videos. Meta's ambitions extend beyond a single acquisition. According to the Wall Street Journal, Meta has raised its 2026 capital expenditure forecast to $125 billion to $145 billion. According to eWeek analysis, a significant portion of this budget is shifting from the metaverse towards physical AI. eWeek further points out that Meta CTO Bosworth has previously stated explicitly that Meta wants to play a role similar to Google's Android in the robotics field. Although Bloomberg reports that Meta is also exploring developing its own robotic hardware, its current strategic focus is more on building a general-purpose software and algorithm platform, making hardware manufacturers part of the ecosystem. This Android dream is not unique to Meta. In March of this year, Amazon acquired Fauna Robotics. According to eWeek, Fauna Robotics is the company co-founded by Pinto, co-founder of ARI. Meanwhile, Intrinsic, Alphabet's robotics software company, was also merged into Google Ontology this year. The competition among these three giants for the intelligent layer of robotics has intensified within the same quarter. 4 months to modify production lines, 22 degrees of freedom, and a candid confession of failure. While Meta was buying brains in Silicon Valley, Tesla was building hands in Fremont. In the Q1 earnings call, Musk revealed that Tesla planned to complete the production line transformation of its Fremont factory within 4 months, dismantling the old Model SX line and installing a brand new Optimus robotic production line. His exact words were, "If we can shut down, dismantle, install, and start up the new line in just 4 months, that's insane speed. I don't think any other company on Earth has ever done that." The initial production target is set for a startup in July or August 2026. In the summer of 2027, the second dedicated production line in Giga, Texas will also begin production. According to Musk's long-term vision described in previous earnings reports, the designed production capacity target is 1 million units per year in Fremont and 10 million units per year in Giga, Texas, with unit costs reduced to levels far below existing industrial robots. Supporting this production ambition is the technological breakthrough of the Optimus Gen 3 bionic hand. According to tracking and analysis from multiple sources, including Financial Content and RoboZap's blog, the Gen 3 robotic hand achieved key design leaps. The number of degrees of freedom per hand doubled from 11 in the previous generation to 22. It adopted a tendon-driven architecture, moving the heavy actuators from the hand to the forearm, controlling finger joints through a cable system similar to the muscle groups in the human forearm, and integrated tactile sensors at the fingertips, improving the precision of force control on different objects. However, this path was not without its challenges. In April 2026, Musk admitted on social media that a patent for a rolling contact mechanism designed for the Optimus finger was scrapped due to unreliability during physical testing. The final production version of Gen 3 adopted a completely different tendon-driven architecture. On the manufacturing side, Tesla is responding to skepticism with concrete results. According to reports from TNW and other foreign media outlets, Tesla has begun deploying Optimus chips for real-world testing at its Fremont and Giga, Texas factories, including battery cell sorting and component handling. The AI-5 chip has also completed tape-out, and Musk stated in an earnings call that it may be the most cost-effective edge AI inference chip. Despite this, Musk is exceptionally cautious in managing his expectations for mass production. Back in January, he posted on X, "For Cybercab and Optimus, almost everything is brand new, so the initial production rate will be agonizingly slow, but eventually it will become insanely fast." This isn't unfounded. The Cybertruck's experience serves as a stark warning. Musk initially projected an annual production of 250,000 units. But according to Cox Automotive, actual Cybertruck sales in the US in 2025 were only slightly over 20,000 units. Tesla did navigate the production hell with the Model 3, but the initial supply chain phase for each new product presents a unique challenge. The hand maker and the brain maker are each missing a piece of the puzzle. Looking at both within the same framework, the divergence in their approaches is very clear. Tesla follows a vertically integrated iPhone model, gigafactories, the FSD data flywheel, and self-developed AI chips, achieving full-stack self-control from hardware to software. Its biggest asset is the deployment of real-world devices within its own factories, continuously acquiring operational data, an asset that no lab or simulator can replace. However, its biggest weakness is equally clear. Managing the supply chain of 10,000 parts is a known, almost unavoidable, war of attrition. Meta's strategic focus is on the software and platform layer, following a horizontal Android model, using top-tier global computing power clusters and an open-source AI ecosystem to build a universal control system where software replication costs are far lower than hardware manufacturing. But its biggest current gap lies here, Without its own mass production factory and a large-scale deployment of real-world devices, where does the physical world training data come from? Tesla's key to success lies in quantity. It has factories, actual machines running on production lines, and data accumulated from FSD. In 2025, it underwent a radical shift in its data strategy. After the departure of Milan Kovac, the former head of the Optimus project, Ashok Elaswamy, the head of FSD, took over, emphasizing learning operational actions from first-person human video. Factory workers only need to wear lightweight camera-based data acquisition equipment to work in a natural manner. According to TechSpot, the previous remote-operated data acquisition mode, which cost up to $48 per hour and required wearing a 30-pound motion capture suit, has been significantly reduced. Meta's key to success lies in data. Wang says it's about learning from human experience, but Meta currently lacks large-scale, self-owned robot deployment scenarios. Tesla dared to shift to a visual learning approach because it has real robots continuously generating authentic physical feedback data in its factories. Meta currently lacks such a data entry point. For its Android to be implemented, it must first answer the question, from whose factories will the training data for the control system come? A worthwhile third-party case study is Figure AI. Figure 02 underwent an 11-month pilot deployment at BMW's Spartanburg plant, participating in the production process of over 30,000 BMW X3 South, according to Figure's official data. Figure's approach is to acquire real-world deployment data in third-party factory scenarios and iterate its self-developed AI model based on this data. However, this also means it lacks both Tesla's manufacturing autonomies and Meta's platform dominance. Android in the mobile phone industry won market share because Samsung, Huawei, and Xiaomi vie to use it. In the robotics world, will hardware manufacturers buy Meta's Android, or will every entrant ultimately follow Tesla's path and manufacture their own? The answer to this question may not truly emerge until the first batch of Gen 3 Optimus rolls off the production line at the Fremont factory